In section 2, we're going to introduce our three-dimensional figures. So we're going to talk about volume and surface area. So volume is just another way to say area of three-dimensional figures. So it's the amount of space that can fit inside a three-dimensional figure. And then surface area is another way to say perimeter of three-dimensional figures. So it's the amount of space that can fit on the outside of the figure. So there are 5 common three-dimensional figures that we are going to be looking at. The first one is a prism. And a prism, there are a lot of different base shapes that you can do for a prism. For example, one of them is a rectangle. So rectangular prism, just kind of review. That's what a rectangular prism looks like. You can have a triangular prism. You can have a square prism. There's a lot of different shapes. But in a prism, what we call all of the faces are rectangles. So for the volume of a prism, the way that you find it is you do the area of the base times the height. So in this case, B doesn't just mean base, B means area of the base. So whatever your base figure is, you find its area using the formulas that we discussed in section 1. Surface area you are going to do 2 times the area of the base plus pH. So B is still the base area. P is now the perimeter of your base. And then H is your height. Next, we're going to talk about a pyramid. So a pyramid is a three-dimensional figure where, again, the base can be pretty much any shape. And then all of the sides of that figure meet at a common point that we call the vertex. So here's kind of an example of a pyramid. So for the volume of a pyramid, what we're going to do is we have to do 1/3 and then the area of the base times the height. So very, very similar formula to a prism. So B and H mean the exact same thing they did as a prism. And then for surface area, so in a prism, all of those what we call faces, or the sides that are not the base, they were rectangles. And in a pyramid, they are all triangles. So what you'll do is you'll do area of the base, because there's only one base shape, and then plus, and then you'll find the area of the triangles, which we do by doing 1/2 P and then L. So P is still the perimeter of your base, but L is something called the slant height. So that is the height of one of the triangles that's on the side. It is different than the perpendicular height, which goes from the vertex straight to the middle of whatever your base is. So the first 2 we talked about, prism and pyramid, they can have any base shape. The next ones we're going to talk about are very, very specific, where they have to have circular bases. So a cylinder and a cone are basically a prism and a pyramid, but the base shape is specifically a circle. So the formulas are a little bit nicer because you know what the area of the base is going to be, and it kind of leads to the formulas being more specific. So the volume of a cylinder, just to kind of draw a cylinder, you've got your 2 circular bases, and then they are connected So that's a cylinder. So for the volume, if you think back to the volume of a prism, area of the base, which we now know for a circle, the area of the base is pi r squared, and then we still multiply by the height. So weirdly enough, if you were to kind of take apart a cylinder and stretch it out, that middle piece is kind of like a rectangle when you kind of spread it out. So for the surface area, 2 times the area of the base, so that's 2 pi r squared, because both of our bases are circles. And then for the perimeter of our base, that is a circle, and we know the perimeter of a circle, also known as the circumference, is 2 pi r, and then our height. So just replacing everywhere you saw area of a base or perimeter of a base with the formula for a circle. So now we're going to talk about a cone. So a cone is basically a pyramid, but with a base that is a circle. So if I want to draw a cone, I have my circular base, and then it meets at the top. So very, very similar. We're going to do 1/3, and then instead of area of a base, we'll put area of a circle, pi r squared, and then times our height. And then for surface area, we do area of a base, which we know is pi r squared, plus 1/2, and the perimeter of a circle is 2 pi r, and if I do 1/2 times 2 pi r, and then our slant height L. So if I notice here, 1/2 times 2 is actually going to simplify. So I can actually get rid of that part, and it just becomes pi r L. And L is still our slant height, just like it was above. Last one we're going to talk about is a sphere. So it's kind of its own little thing. So a sphere, just draw a picture. It's basically a 3-dimensional circle. That's the best way I can draw a sphere. The formula for volume and surface area of a sphere are not really easy things to explain how they came about. So I'm just going to tell you what they are. It's not really related to pyramids or prisms or cylinders or cones. So the volume of a sphere is 4/3 pi r cubed. And then for the surface area, we have 4 pi r squared. Again, it takes a little bit more to kind of explain where those formulas came from, so I'm not going to go over it. So when it comes to applications of volume and surface area, which we are going to talk about a lot of different ways you can apply these, is, for example, if you have a swimming pool and you want to know how much water it takes to fill it. So a swimming pool is basically a cylinder or a rectangular prism, depending on what type of pool you have. So filling it is volume. If you want to figure out how much air will fit in a balloon or a basketball, those are kind of like spheres. And then very common in the construction field is how much paint do you need to paint a house? That has to do with surface area, because you need to figure out how much area you have on the outside of that house that you need to paint. So let's take a look at a couple examples. So in our first example, you just bought a new above ground swimming pool and need to fill it with water. The pool is 52 inches deep and has a diameter of 24 feet. How many gallons of water are needed to fill the pool to 48 inches, and what about 36 inches? And just because we are talking about gallons of water, 1 cubic foot is about 7.48 gallons, because we will need that. So anytime you buy an above ground swimming pool, you want to think of it as a cylinder. So above ground swimming pools are shaped more like cylinders. So you think in terms of, I have a pool, it's kind of wider at the top and then it goes down. This is kind of what an above ground swimming pool looks like. So we know the entire height of the pool is 52 inches, And we know the diameter, so from one side to the other, is 24 feet. Now, when you fill a pool, you don't fill it up to the very top. You fill it up to a specific depth. And in this case, we want to fill it up to 48 inches. Now, I can't have one part of my formula in inches and the other part in feet. So I do need to convert 48 inches to feet. And the way I do that is I divide by 12, which gives us 4 feet. So we're trying to figure out how much water do I need if I fill it 4 feet. The second part is 36 inches, which when divided by 12 is 3 feet. So we're trying to figure out how much water do I need for a 4-foot depth versus a 3-foot depth. So we're going to use our volume of a cylinder formula. So we're going to do pi times our radius. So our diameter is 24 feet, which means our radius is going to be 12 feet squared, and then times our height of 4. And we aren't going to leave this in terms of pi because I want to know exactly how much water I need. So it doesn't really make sense for us to leave our answer in terms of pi here. So the volume of the pool is going to be 1,809.56. And then for volume, our units are cubed. So it's going to be feet cubed. Now that I know how much volume I need water-wise in cubic feet, I need to now convert this to gallons. So I'm going to do 1,809.56 divided by the 7.48. And we're going to get 241.92 gallons. And again, not really going to have a decimal gallons, so we'll just round that up and we'll say about 242 gallons. Because you can order water by gallons, and so it's roughly 242 gallons. Okay. So for the second part, 3 feet depth. So still going to be pi times 12 squared. And now my height is 3. Which is going to give us a volume of 1,357.17 feet cubed. So to figure out how many gallons that is, I do 1357.17 divided by the 7.48. And we're going to get 181.44 gallons, which again, we're going to round up to a whole number. So about 182 gallons of water. So very large difference in the amount of gallons of water you need if you change the depth from just 3 feet to 4 feet. So even though it's only 1 foot difference, it affects our volume a lot more than you would initially think. Okay. So for our last example, we have decided to paint our new shed and need to know how many gallons of paint you need to buy. You are only painting the walls of the shed, not the roof. So we're going to only look at our rectangular prism. How many gallons of paint do you need? So this is an example of something called a composite figure where you have 2 3-dimensional figures combined. And we'll talk more about those in our next section. So for right now, we're going to ignore the roof. And we're only going to pay attention to the rectangular prism, which is the walls of our shed. So if I'm going to paint the walls of my shed, I'm going to be finding its surface area. So I want to use the formula for the surface area of a prism. So we have 2 times our base shape plus the perimeter times the height. When you have a rectangular prism, you get to pick what rectangle is your base, because in a prism in general, the non-base sides, which we call the faces, are rectangles. And if your bases are also rectangles, you've got choices to make. So I'm just going to go ahead and choose the rectangle that faces us to be my base rectangle. So we know the length of that is 20, and this 15 is also going to be the height of that base shape. So we're going to do 2 times 20 times 15 plus, and then for my perimeter, I'll have 20 plus 20 plus 15 plus 15, because it is a rectangle. So we have 2 sides that are the same. And then for the height is going to be the side that connects your 2 bases. So in this case, my height is my 45 feet. So times 45. Now I'm just going to do some simplifying. So 20 times 15 times 2 is going to give us 600. And then 20 plus 20 plus 15 plus 15. So this is going to be 70, which we're then going to multiply by 45. And we get 3,150. So we'll do 600 plus 3,150. And we get a total surface area of 3,750. In this case, it's going to be feet squared. And the question does ask us how many gallons of paint do we need. So we're going to have to convert our square feet to gallons. Now, weirdly enough, the amount of gallons in a square foot and the amount of gallons in a cubic foot are the same. It's 7.48. So we're going to be dividing by 7.48 again. So 3,750 divided by 7.48 is going to give us 501.34 gallons, which again, we have to round up to a whole number because you can't really buy paint in decimal gallons. So we need about 502 gallons of paint. So let me know if you have any questions about surface area or volume or any of the formulas that we discussed.